So today we are going to discuss about need to standardize units. Whether is there any need for us to standardize the unit. So yesterday we have seen the olden days, the traditional way of measuring was a cubit. That means cubit means what? The length from our elbow to the tip of the middle finger. This length is called a cubit. And yesterday I have shown that we were measuring, if I want to measure the board, I will be measuring 1, 2 like that. I used to measure. Or I can use my hand span. That means I will be measuring the means from here to here. If I want to measure, I will use my hand span. Then I can tell that this is 1, then this is 2, then I will tell about almost 2.5, not even 2.5. But here the problem is that we are not able to get an accurate value. Science means we need, why we are standardizing value? Actually we are standardizing value because we need to standardize the units because we need an accurate value. For example, when we are measuring in the science, whatever phenomena is happening, we are not just assuming like that it may happen. Or when we are performing an experiment, the result is always a sharp value. We will never go for an error value, or we will never, if we want to get one answer as 2 kilometer or 2 centimeter, we will never go for 2.1 centimeter, or we will not go for 1.9 centimeter. We will opt only accurate value, that is 2 centimeter. So here comes that problem with the traditional units. Traditional units, as a result, I have this is almost 2.5. Now, if you measure, what will happen? My hand span is bigger than you. Sure. So if you measure sometimes, you will be getting answer as 3. I was getting almost 2.5, but you are getting 3. If one person who is having hand span bigger than me, sometimes he will be getting the value 2. So if these 3 values are getting for the same length, I cannot say that these are wrong, because traditional value we used to count with our hand span or our cubit. So this is the problem. Or food. Yesterday we have seen about food system also. In food also, depending upon the size of the person, the food size also can be different. So we cannot measure for an accurate value. Then, so we need an accurate value or specific value. Even yesterday we have seen about, if you are going for a shop, you need exact, if you want to purchase 1 kilogram of sugar, you need exact value 1 kilogram. You will not pay, if it is less than 1 kilogram, you will not pay for a 1 kilogram. If it is more than 1 kilogram also, you will say to the shopkeeper that you need only 1 kilogram. So this is the need to standardize the units. We need an accurate value, or we need an accurate unit which is accepted in worldwide. So from the traditional units, when we are moving, in 1791, the French Academy of Sciences developed a system to measure the units. Was not only simple, but this was scientific. That means scientific means it was accurate. Now, in this system, length was measured in meter. Length was measured in meter. Then after that we have since the length was measured in meter, they have known this one as metric system. They have just named that one as metric system. Metric system. So we are just moving from the traditional units. We are just moving from the traditional units in order to get an accurate value. So in 1791, French Academy of Sciences have developed a system which was scientific. There they were expressing length in meter. So named for that, they have named for that system as metric system. Okay, metric system. The unit of mass was named, length was in meter, then mass was in grams. They were discussing about that, their unit was gram, and time, the volume was given as a liter. Volume means, if you want to measure the liquid and all, they were you going for liter. So mainly they were having three fundamental units in metric system. Length they were measuring in meter, then mass they were measuring as gram, and volume they were measuring as a liter. Okay. Then after that again, with the passage of time, the metric system has given two variants. That means again they have updated this metric system. By long time they have again they thought that there should be an updation should be there. So they have divided this metric system into two categories. One is CGS system and another one is MKS system. One is CGS system and another one is a MKS system. Okay, so CGS system, CGS from here the expansion, C stands for centimeter, G stands for gram and S stands for time, seconds. Okay, so they were measuring length in CGS system. The metric system was divided into two, CGS system and MKS system. In CGS system, they were having measuring the length by centimeters, then mass as a gram and time they were measuring as a seconds. Time they were measuring as seconds. And just an updation to this one, they have also using MKS system. In MKS system, they were measuring this one as meter. They were measuring length as meter, as we have discussed. This is metric system. Then K they were measuring as kilogram. That means measuring of mass. They were using as a kilogram. And S same time, that is seconds. So this was the two systems before SI system. First one was, yesterday we have discussed about the traditional system. In traditional system, they were using a cabinet or a handspan they were using, or they were using foot. Then after that, in 1791, they have updated this one to metric system. Why we have named this one as metric system? Because they were measuring length in meters, so they have named as metric system. And when the time is going, the scientists have again updated this metric system into two, CGS system and MKS system. Nothing, very simple. CGS system, they were measuring length as centimeter, then mass as gram, and time is in second. And in MKS system, they were measuring length in meter, mass is in kilogram, and time is in second. Now, again, after that, we have defined the SI system or Standard International System for the measurements units. So, in metric system, we are having CGS and MKS. Then, after that, we are going to for the SI system or Standard International System, which is followed downwards. Okay, so in standard, yesterday we have seen about fundamental physical quantities. How many fundamental physical quantities were there? There were 7 fundamental physical quantities were there. First one was length, then we have seen about mass, then we have seen temperature, then time. Up to there we will discuss in this chapter. After that 3 more are there. One is electric current, then luminous intensity, and the final amount of substance. Now, these physical quantities, that means during the 20th century, the MKS system became more popular than the CGS system. Okay, this MKS system has become more popular than CGS system. Why? In CGS system, we are measuring length is in centimeter and mass is in gram. So, if you want to measure, that means 1 meter will be equal to 100 centimeter. So, if you want to measure the distance from one city to another city, sometimes that will be 10 kilometers. That means it is very easy for us to express in kilometer than expressing in a meter, expressing in centimeter. If we are expressing centimeter, the value will be very high, and for the numerical functions, we will face so much difficulty. So it is for us, it is very easy to use meter rather than centimeter. If you want to measure your length of your pen or the length of the small units, we will use for a centimeter. But if you want to measure the length of our room, we will never go for a centimeter, we will go for a meter only. So that the addition, subtraction, multiplication will be easy for us. Okay, so that's why by the 20th century, the MK system has become more popular than CGS system. Then again, so then after that what happened? The existence of two systems. And nobody has banned this one. Some people will use CGS system and some people are going to use a MK system. But MK system was used more. Now one problem is there. Sometimes I am using CGS system. Sometimes you will be using MK system. So you are expressing something in MK system and I am expressing something in CGS system. So surely there will be a doubt will be arised. Okay, or if I want to study about your studies or your recordings, your measurements, I have to convert whether to MKS to CGS system or CGS system to MKS system. Okay, that's what happened in worldwide. In some scientists are there, the one part of the world, they will be using CGS system. And some scientists, whom they are living in the other side of the world, what will happen? They will be using MKS system. So in science field or in the branch of science itself, there was a doubt what was arised due to the usage of these two systems. Okay, so in order to overcome from that doubt, or in order to overcome from that difficulty of converting from one system to the other system or from the other to this system, the scientists have decided to have a standardized unit or standard international unit or SI unit. Okay, so in 1960, General Conference of Weights and Measurements met at Paris. They were having a meeting or they were having a conference at Paris in 1960 and they have adopted International System of Units or SI System of Units. International System of Units or SI System of Units. So we have moved from first one traditional system, then after that 1791 we have seen about the metric system. Then metric system there was two systems were there, CGS and MKS. And in 20th century, the beginning of 20th century, MKS system has become more popular than CGS system. Then after that, there was a doubt was raised because of usage of these two systems together. Then in order to overcome that one, in 1960 at Paris, there was a conference by the scientists who were participated from the different places of the earth, and they have developed the SI system or standard international system. Up to this it's clear now. Now you can look at page number 19. There is a table is given, table 3.1. So there you can see we know that we are having only 7 fundamental units. So in 1960 from the Paris, they have developed a SI system. Means what? They have decided to give a standard measuring unit for these 7 fundamental quantities. 7 fundamental physical quantities. So length they were using as meter. Length they have used as or the unit was in meter. Then mass they have given us kilogram. Mass they have given the SI unit is kilogram. Symbol is kg. Then time they have given us second. Then after that we will discuss about temperature. Temperature they have given us the Kelvin or K. Then these are the 4 physical quantities what we are discussing this chapter. Then after that electric current was there. They have electric current they have given us an ampere. Then the substance, the amount of substance they have given us mole. Maybe in chemistry you will study that one. Then finally luminous intensity they were using as a candela. Okay, luminous intensity they were using as candela or CD. So keep in mind that these 3 we are not discussing in this chapter. The later classes you will be studying, but you will be just studying what is the SI unit. The symbol and the name you have to study regarding electric current, then amount of substance and the luminous intensity. So these are the 7 fundamental units which was given by the scientist in 1960 at Paris, and this is known as SI units or standard international units, and this will never change as long as the world or the science exists. These fundamental quantities, the unit of these fundamental quantities are not going to be changed. So this is very important. We need these units from in class 6, 7, 8, 9, up to where you are studying physics, you need these fundamental units. So this table 3.1 is very, very important. You can just mark there on your textbook. This table 3.1 is very, very important. Now, moving to the next step. Units of derived physical units. This is fundamental physical unit. Is it now? Now, from here, how we can measure the units of derived physical units. So, derived physical units means already you know. If I want to measure area, I need a length into breadth. Length into breadth is area. Okay, so both we are measuring in meter. So, what will be the SI unit? Length of SI unit is in meter. Already we have seen now. Again, length of breadth also we are measuring in meter. So SI unit is meter. So meter into meter, meter square. Meter square will be the SI unit of area. Meter square will be the SI unit of area. So if you know this 7 fundamental units, you are able to find out any other derived units from these fundamental units. Okay, now again, if you want to find out the volume, SI unit of volume, we know length into breadth into height. So these all are in meter. Length is measured in meter. Meter into meter into meter. So what will be the SI unit of volume? Meter cube or a cubic meter. Meter cube or a cubic meter. So like that we are able to find out the SI units of derived physical quantities from the fundamental physical quantity. Okay, now next one we are moving to multiples and submultiples. What is multiple and what is submultiple? Multiple and submultiples. Okay, so we have seen that we are using the SI system as a, maybe we are using for a length mass we are measuring. If we are measuring length in SI system, it is in meter, in mass is in kilogram. And sometimes we will not be able to measure everything in meter. Suppose if you want to measure the length of this chalk piece, okay, this length of this chalk piece only this much will come. This is very difficult for us to measure in meter. In meter means you will be measuring 0.001 meter or 0.023 meter, like that you will be measuring. So there will be numerical values will be coming, which is very difficult for us when we are doing the mathematical operations. So for that one we will be using centimeter. Instead of meter, we will use a centimeter. So centimeter is lower quality than meter. So any quantities, units what we are measuring, which is less than the SI unit, is called as submultiples. Okay, meter we will use a centimeter or millimeter, which is familiar for you. In your scale, you can have 15 centimeter scale in your instrument box. There you can have a 15 centimeter you will get, and each 1 centimeter is divided into again 10, and each one small division is equal to 1 millimeter. Is it now? So millimeter and centimeter will be the submultiples, smaller quantities of meter. Smaller quantities of meter. Meter is the SI units. And now, if I want to express the length of the distance from Salembur to Devariya, it is very difficult for me to express in meter. It is I can express in meter, but if it is 30 kilometer, 1 kilometer is what is how much meter is 1 kilometer? 1000 meter. Okay, so 1000 meter is 1 kilometer. If there are 30 kilometers, 30 into 1000 will be there. that much meter will be there. So that is also very difficult for me to express in SI unit. So I will go for multiples. So what will be the multiples? Multiples are the units which is bigger than SI unit. Multiples are the units which is bigger than the SI unit, and submultiples are the unit which is lower than SI unit. Okay, then you can just look at your textbook page number 20, table 3.2. Page number 20, table 3.2. So what are given there? Multiplier is there, prefix length, mass, capacity or volume is given. Then if it is very small, we will use as millimeter. As I said, millimeter we will use. Then mass, if it in case of mass we will use milligram. Then we will use a milliliter for liter. Then if it is a centi, length is in centimeter, mass is in centigram, and finally centiliter. Then if it is there is one more is there deci, that is 1/10 part, that normally we are not using, but it is given in the textbook that you can just go through that one. Deci, decimeter, decigram and deciliter. After that it is given 1, multiplier 1 up to there. First 3 are submultiples. First 3 are submultiples. Then 1 is given in that there, that is meter, gram and liter, or meter, kilogram and liter. That is actually SI unit. Then again it is 10 times means decameter, decagram and decaliter. Then 100 means hectometer, hectagram and hectoliter. These two we are not normally using generally, but you have to keep it in mind. But the last one we will use 1000, multiples of 1000. Then meter will become kilometer, gram will become kilogram, and liter will become kiloliter. Okay, so these are the multiples of the SI unit. These are the multiples of SI unit. So what is multiple and submultiple? Multiple is the higher units of the SI unit, whereas submultiple is the lower units of SI unit. Then again, guidelines for writing SI unit correctly. Okay, guidelines for writing SI unit correctly. You know, in science, even both in physics and chemistry, we are using symbols. Already in physics chapter, in second chapter of chemistry, you have studied about symbols. And in the exam, I have asked you to write the symbol of the chapter. Then I have seen that some people were writing this H2O, this H2O, like that they were writing. Okay, then if I have asked calcium oxide, some people were writing CaO. Okay, CaO. There are some terms and conditions which should be followed by when you are writing a symbol. If you are not following these rules, your answer will be wrong. Your answer will be wrong. So what are the rules or the guidelines when we are using the SI units? So first one, you can look at the page number 20, table 3.3. Unit names. That means guidelines. A unit is generally written in small letters. That means if I ask that what is the SI unit of length, you should not write. That means it's a one-word answer. Answer is meter. But when I am asking that one in the exam, if you write meter, that means capital letter meter, then what will happen? This is wrong. We will never use capital letter when we are writing the names of a symbol. We will be using only small letter, that is meter. That this one is correct. If you are writing this one like this, then that will be wrong. Then what is the next case? If a unit is derived from the name of a person, its name is always written in small letters. Even if it is derived from the person also, the name will be written in small letters. For example, Newton. That means the unit of force that we will discuss later, that is Newton. Isaac Newton. In order to honor Isaac Newton, we have given the name of the unit as a Newton. But you will not write Newton like this. Capital letter you will not use. This will be wrong. You will be writing only Newton. So in the exam, if you are writing capital letter, the mark will be 0. If you are writing only small letter, then only you will get the mark. Then again, the next one is unit of symbols. The symbol of a unit is normally written in small letter. See. If this one meter, we already know. This is the correct word. We will use symbol also in meter. We will not write capital letter M or second as small letter S, not a capital S. If you are writing this one, that means you are getting an answer 20 meter. If you are writing 20 meter, this is wrong. You have to write as 20 small letter meter. Then only that will be correct. Then again, if a symbol of a unit is derived from the name of a person, suppose if the symbol is derived from the name of the person, at that time this will be changed. This will go for a capital N, not the name, symbol. Symbol will become capital N. Okay? That is the ampere is there. Ampere, it's a unit of SI, unit of electric current. Ampere is the scientist which is has given much distributions to the electric current. So in order to honor him, we have given as a ampere. So when we are writing, we will use only small letter ampere, but that symbol will become capital A since that is the name of a person. Since that is the name of a person. Then again, same time, if one person has derived 2 units, then we cannot go for the name of that person. At that time, what we will do? We will go for first 2 words, 2 letters of that unit. That means Pascal is the unit of pressure. We will go for a P and second letter is small letter PA. Or the sound we will discuss about here. The SI unit of hertz. Hertz is their frequency. We will write hertz. Then that will be we will be using as a H is a capital H and a second letter Z. Okay. Then prefix names. Again we are telling that milligram. Submultiple sometimes we will use a centimeter, millimeter. Millimeter means we will not use with the capital letter millimeter. No, we will using only small letter milli. After milli there should not be any hyphen or there should not be any space. You will be continuing the writing millimeter, even if it is coming in the first of the sentence. Then again, next one is prefix symbols. That means symbols also, prefix also is given like that. Milligram. You are not going to write milligram as capital MG or the capital M and small letter G. No. Milligram also symbol will be small letter mg. Small letter mg. Then plurals. We will never use plurals for the units. That means we will never say 10 meters. We will never say 10 meters. We will say only 10 meter. Or we will not say 100 meters. We will use only 100 meter. But when you are writing plural, you will write only this much only. You will not use S. There will not be any plural form. You will be having only that same name. Then 10 seconds you will not write 10 seconds or you will use only 10 seconds. Then next one is punctuations. That means when you are writing 50 centimeter long wire, 50 centimeter long wire, this is a sentence it is going like that, then you will not use a full stop here. There is no punctuation mark after writing the SI units. Okay, these are the guidelines for writing the SI units correctly. These are the guidelines for writing the SI units correctly. Okay, this is all about today's portion. So we have seen about how traditional units, what was the need of traditional unit to standardize that one. Then after that we have seen about how we have come to the SI units. Then we have seen multiples and submultiples, and finally we have seen about the guidelines for writing SI units correctly. Okay, so you have to read this one very well, and this table 3.1 and 3.3 is very important. You have to read minimum 5 times that one. You have to by heart that first one, 3.1. Okay.